and welcome to everyone to this webinar. I'll start with a little bit of context for this webinar. So in the power system industry, there is a grid modernization and digitalization that is due to a wide deployment of new technologies. It happens at all levels, the substation, transmission, distribution. We are adding automation at all these levels. We're adding new distributed energy resources, integration, and we have more advanced two-way communication networks. So it's not anymore only about reporting, but we're sending a lot more comments. We are developing synchrophaser systems. So there are a lot of new things that bring a lot of new technologies that are communication-based. And as these new technologies are adopted, the grid is becoming more vulnerable to cybersecurity threats that are both malicious and accidental. So I'm going to cover a little bit of the content on this. When we're looking at accidental threats, we're looking at software and hardware failures, so crashes, bugs, things that will happen with the communication equipment that are not necessarily related to cyber attacks. There can be also human errors based on IBM research. There are a lot of sources to this, and they are the main source of communication network downtime. So we're looking at misconfiguration of server hardware, OSs, applications, and devices. We're looking at failure to upgrade or size the servers to accommodate more data and computer-intensive workloads. We're looking at failure to upgrade outmoded applications that are no longer supported by the different vendors. We're looking at failure to keep up to date on patches and security. And all this can also be because of overburdened IT departments, lack of training. There are plenty more sources, but it's important to understand that in the context of having more and more communication in the network, in the power system grid, it can lead to problems that that would occur less often before when there was less communication, and we need to take them into consideration when studying the modernization of the power grid. On the other side, we're looking at malicious threats as well, so the rise of risk for cyber attacks. There was one very good example that I intended to show here that was reported by Schweizer Engineering Laboratories, which is a cyber-induced power outage that happened in Ukraine in 2015. And here is a diagram of the step-by-step how this attack actually occurred. For more information, you can read their full article. But I wanted to go through to give an understanding of how these cyber attacks can have an impact on the power grid. So it all started with email phishing. So this is one big source of error. It's a human error. Then they could have access to the network. They started reconnaissance and enumeration of the network to provide an initial backdoor for the hacker. Then they had access and discovery of the Microsoft Archive directory servers that contain corporate user account and credentials. The next step was the use of encrypted tunnel from an external network to get inside the control system network. So we're right here in the diagram. Step 5 was the discovery and access of the SCADA HMI due to improperly configured firewall. Again, a human error here. Control override of HMI operators and breaker opening commands. So the network started, this is where it started having an impact on the power grid by opening a breaker. They also did several other actions with the intent of complicating the response of control operators to make sure that they could not stabilize the network quickly. So as they were already in the communication network and had control of the HMI, they had also the power to prevent the operators from efficiently responding to this attack. And in the end, they also tried to run a kill disk malware to wipe out the control center HMI and workstation. This can have very serious consequences. So this here is just a single example of a step-by-step procedure that hackers can take to attack a power grid. and with the increasing amount of communication technology that's attached to the grid, it's a risk that's becoming higher and higher, and that needs to be studied, better understood, and to be able to find ways to mitigate the impacts.